This is some pickup activity I did where I designed essentially the same telescope I had in the 8-inch, but for a 10-inch f4 size using a Coulter mirror. I had built basically a 24-inch shell, and the intent was to have this made commercially, and actually this part was fabricated by a fiberglass house. They used my tooling and made this shell. Then I completed the basic telescope in using the Coulter F4 system. Unfortunately, I never did actually go into marketing this. This is another frontal view of the same system. It's a 10-inch f4 Richest field in a 24-inch sphere. This is another view of the same system using a new wide-angle lens I just bought. For the basin, I was utilizing a 20-gallon nursery planter container. It worked out actually quite handy. This is the same telescope from a side view, and now from basically a 3/4 view. This is the 10-inch Cassegranian in the 24-inch sphere, set out in the same location in my Bonita house. This is just prior to my start of the reconstruction of this whole telescope into another basic configuration. Problem I was having is that the internal optics were in the tube assembly, which would slip into the sphere. I would get a trapped air mass that would bleed out and give me air turbulence problems. So I decided to remove the inner sphere, the inner tube assembly altogether, and basically make a permanent short tube which would flare off of the basic sphere, and make separate hardware to install and handle the mirror. I also would put in a service access port on the sphere top side in order to install and get the mirror out, since I was going to make the tube permanent from this point. For this, I was decided that I was going to use a Coulter 4-inch Richest field telescope in a 5-inch diameter tube, and I was going to mount it as my finder scope. So I set up a template with a 5-inch diameter circle, and I set that up square against the face of the tube. Then at nighttime I aimed this at a street light some distance away, and this caused the circular disc to cast a shadow on the basic sphere. And then I traced this outline of this 5-inch cylindrical cone in effect, and this would be my cutout to provide me my access for installing the mirror and also installing the finder telescope. This is a view that shows that shadow line. Actually, it's the smaller interior shadow line. I determined that I needed a larger size than that to install the mirror, so I developed an elliptical form shape that would be large enough and mark that on the surface. Now then I would go through and cut this detail out. Notice that this runs right through my old original finder assembly, so what'll happen is that there'll be a lot of cutting and pasting and filling on this, but that's a nice thing about working in fiberglass, that it's really quite flexible. I was going to need to basically machine in a small recessed shelf in the sphere structure itself in order to have the flared tube assembly basically lay in place. So I set up a template with my router that would key off the existing hole and basically cut in a perfect recess of a set diameter and a set depth. Note here that I've already made my cutout for my service access port, and then here the router is basically set up to right around the existing opening and cut in a very shallow recess. It's all set to start here, and we see here after the routering has been completed, notice that it has cut a shallow recess. There are a couple of places where it's gone deeper and cut through, but that's no problem, because when I fiberglass assemble it and lap it in, that'll all get filled up and it'll all get cleaned out. It'll be pretty clean. I actually used my old tooling from the 10-inch Richest field configuration, but I put in a plastered dam to shorten the tube assembly, and what I've done is then I've laid up a fiberglass in that shortened assembly, and then where that flares out, that will be again trimmed to match the existing sphere. This view shows all the parts assembled, all bonded together. And what I've started to do, the dark patches are areas that have nicks and dings and cuts, and I've filled them with a body filler for lacquer body filler. And this will all basically get cleaned up, overcoated, and painted, and you'll see none of these marks. Here the part has been all sanded and cleaned up, and it's ready for the paint. The surfaces are very clean, but it just needs a paint coat. This is after it's been painted now with a white lacquer, acrylic lacquer. And again, another view. The finder assembly from using a Coulter 4-inch mirror was set up in a 5-inch diameter aluminum tube. This was set up to slip inside of the fiberglass detail that interface with the sphere. You can see a part of this detail, which is that curved shape which runs diagonally across the telescope. Since I no longer had the tube to mount the telescope optics conventionally, I built this structure to sit at the base of the telescope to be bonded permanently in place. Then inside of it I have small gear hardware and right-angle drives that I picked up war surplus that would access my diagonal mirror, which would be located on the top of this 1.25-inch diameter brass center stud. This view shows the fiberglass detail right straight on. You can see the provision for the 3 mounting thread studs, which I would do the adjusting. The thought was that I would actually say, if I was to do this in production and make this part as a cast iron casting, and that then would serve as my counterweight. This is my back-end hardware assembly. You've seen all the center structure. To the left is the connecting shaft that runs through the vertical shaft, and onto this would be mounted the diagonal mirror that diverts the final optical path to the side of the system. The flex shaft on the right actually will interface with a right-angle gearbox drive that you see at the base of the assembly. That is what I'll use to toggle and to rotate my diagonal mirror to one of 2 positions, so I can use either a conventional 1.25-inch eyepiece or the built-in wide-angle Urfel. Here you see the hardware installed, with the shaft installed, and the flex shaft also coupled. What we see here is a finished assembly. The access for installing the mirror is through the large opening. The large Urfel eyepiece is the one viewing station. The flex shaft, operated through a small knob, which is not quite visible in this view, will alternately rotate the mirror between 2 stops that will either put it to the Urfel or to the standard eyepiece on the right side. So I can use a powered eyepiece on the right, switch back to the Urfel using that as a finder. This is the completed and assembled telescope. This shows the finder, the 5-inch finder assembly installed in the cutout, and this is basically the working configuration. More views of the same. And basically the final view of this one.
In 2003, I developed a laser collimating system for collimating a Cassegranian primary mirror, which normally has no on-axis surface. I did this by creating a virtual pinhole. I first rough aligned everything to start pretty close. Then I removed the secondary and replaced it with a 1/16-inch diameter aperture stop. Because of my sphere mount configuration, I had an additional little problem in that I had a tertiary mirror, and I had to make sure that my eyepiece was aligned up with both the mirror and the final optical axis. So I had to go through an iteration to first establish that particular alignment. I did this by setting up a laser pointer in the secondary, which would shine through that aperture stop to the exact center point on the primary mirror. I took out the pen light from the secondary assembly, opening up the passage so that it was clean, and then inserted the collimating laser eyepiece in the eyepiece holder and adjusted that until that reflected back down onto the tertiary mirror, which was already aligned, and the beam then found its way to the pinhole and passed straight on through. And from that point, I'm reflecting film to get the primary mirror collimation.